Good morning, children. Here is the third class of yours. As you all know, class 11 years, right? This subject is called as computer science, not computer application. First of all, let us be familiar with the subject name first. Those who are done in the class 8, 9 and 10, they are known as computer applications. Computer applications, right? What you are doing here is called as computer science. And distinguish, I'll take a minute or two to distinguish between these two. Right? I must have told you in the lower classes also that might be some newcomers, but still, here I go. What is the difference between computer application and computer science? As you all know, there are other counterparts. I mean, your friends, those who are not taking computer science. They also know how to use a computer, you also know how to use a computer. We don't know, they can use far better than you. Or you can be much better than them. Handling, usage of the computer is not a big deal. What is the strength is? You command your computer. That is what you have chosen this subject. I repeat again. There is an app, you use an app, it's not a big deal. Or you have been given a training, or you must have learned self-acquired knowledge. Maybe that. Using a computer is not a big deal. Just born babies, they use it. The toddlers who can't even stand on their own foot, they start using the computer in the, what we call modern countries, advanced countries, that you know. Right? In Japan in particular, when the baby is in the womb, they start teaching. Let's keep this story apart. Let's come to the focal point. What is the difference between computer applications? What is the usage of it and how do we apply them? How do we? Applications. Right? Applications of the computer. This science, we will be going with in-depth knowledge of computer science. Class 11ers and 12ers, the subject name is called as computer science. Right? I told you in the very first class, right? No matter whichever the background you belong, you can be a commerce student, you can be a bio student, you can be a pure mathematics student, you can be a humanities student, immaterial what your background is. This subject, it will suit the need of each and every discipline which you opt for. Okay, the student of law, they take computer science. The botany student, they take computer science. Right? So you need to know. Now we are going to get back into a chapter called this number system. Other day I did introduce 4 number systems: binary, octal, decimal and hexadecimal. As we all know, among the 4 number systems, we are familiar with one and the only number system which we have been using over the decades. From your point of view, right from LKG till now, you have been learning only one number system is called as decimal. Deci means 10. Some authors they say 10 number system. Okay, boys and girls? Now, your computer is capable of using one of the 4 number system. But predominantly we give in decimal and we get back in decimal. Internally, it uses binary. Predominantly, it uses binary. It uses octal. It uses hexadecimal. Let's have a simple arithmetic we learn. As I told you, again I am repeating, boys and girls of 11ers, this subject doesn't have any mathematics. We need not to solve. But this chapter happens to be that you need to be familiar with the numbers. So from one number system to another number system, we need to convert. So for which simple mathematics like second table, 8th table, 10th table and 16th table you need to be familiar. Don't worry, I am there to help you out. Now, today what I intend to do is this, boys and girls. I'll take a number, a decimal number. I will convert the decimal number into binary. I will convert the number into octal. I will convert the decimal number into hexadecimal. I repeat again, from one number to other 3 number system which I am going to teach you. Quite simple. Quite simple. I'll make it simple for you. You will understand it. For which you need to watch the entire video. I know this is the age. You past class 10, you are in a very high spirit, you will not be having a mood to listen this video. Okay, the parental pressure is there. We the teachers, we have no physical contact, we are there in the virtual classes, right? But still you need to know your responsibility. Okay, the external force will not be keep telling you, hey, keep studying, keep studying, keep studying. Anyhow, I'm going to take up one decimal number, right? I'll convert into binary, octal and hexadecimal in a very simplest way possible. Here I go. Now, for example, any number subscripted or suffix, if I write this, is known as decimal number system. If the base is 10, as I told you, if the base is 2, is called as binary. If the base is 10, is called as decimal. If the base is 8, is called as octal. If the base is 16, is known as hexadecimal. Here I go. What does it signify? 743 of decimal, you need to convert. Convert 743 of decimal to binary. Binary means it is, I will not say suffix, it's subscripted. What do you mean by superscript and subscript is, if you write on top, for example, x to the power of 16, this is called a superscript. Here, y4, this is called as subscript. Right? Subscript or superscript, otherwise you can use a colloquial language prefix and suffix. Let's not do that. Let's not use the word of the suffix. Underneath you must write, if it is to 743, you must convert 743 of decimal to binary. Same 743 of this one I want to convert into octal. Same 743 of decimal to hexadecimal. As you all know, there are only 4 number systems, boys and girls. Just 4 number systems. They are binary, octal, decimal and hexadecimal. Just for an example, convert 743 of decimal, all of them are decimal to binary, decimal to octal, decimal to hexadecimal. Decimal to other number system is quite simple. If you want, in binary, keep dividing by 2 till you get less than 2. Quite simple. Processes, all 3 of them are identical. All are same time. I repeat again. If I want to convert from decimal to binary means, keep dividing this one by 2 till you get less than 2. From decimal to octal means, keep dividing this 743 by 8. Keep repeat this process till you get less than 8. Similarly, 743, you keep dividing by 16 till you get less than 16. This is a quite simple process. If I do it within seconds, you will understand. As I told you, what you need to be familiar with this: second table, 8th table, 10th table, and 16th table. Right? Let's revise. How do I do this? 743. Convert. As I told you, because I want to convert it to binary, keep dividing by 2. 2 3s are 6. Remainder is 1. 1 and 4 is 14. 7 4s are 7 2s are 14. Then 2 1s are 2. Remainder is 1. This is very, very crucial, boys and girls. The remainder 0 or 1 only will come. That needs to be taken and note of it without mistake. I repeat again. 3 2s are 6. Otherwise, 3 2s are 6. Remainder is what? 1. 1 and 4 is 14. 7 2s are 14. 2 1s are 2. Remainder is 1. I repeat again. 2 1s are 2. 2 plus 1 is 3. 7 2s are 14. Remainder is 1. 2 3s are 6, 6 plus 1 is 7. Got it? I repeat again. 2 1s are 2, 2 plus 1 is 3. 7 2s are 14, remainder is 1. I keep it in my hand. 2 3s are 6, 6 plus 1 is 7. Again repeat this one by 2. Divide by 2. 2 1s are 2, remainder is 1. 1 and 7 is 17. 17 is 5 2s are 16, remainder is 1. 1 and 1 is 11. 5 2s are 10, remainder is 1. I repeat again. 5 2s are 10, 10 plus 1 is 11, remainder is 1. 2 8s are 16, 16 plus 1 is 17, remainder is 1. 2 1s are 2, 2 plus 1 is 3. Again repeat this one. 9 2s are 18, 2 2s are 4, remainder is 1. Again divide. 4 2s are 8, remainder is 1. 6 2s are 12. 6 2s are 12, remainder is 1. Then 4 2s are 8, 8 plus 1 is 9. Again divide this one by, remainder is 0, mind you. Remainder is 0, I am taking note of it. 6 2s are 12, 12 plus 0 is 12, remainder is 1. 4 2s are 8, 8 plus 1 is 9. Again divide. 2 2s are 4, 2 3s are 6, remainder is 0. Again divide this one by 2. 2 1s are 2, 2 1s are 2, remainder is 1. 2 1s are 2, 2 plus 1 is 3, 2 1s are 2. Again divide. 5 2s are 10, remainder is 1. 2 2s are 4, remainder is 1. Last one. 2 1s are 2, remainder is 0. I repeat again. 2 1s are 2, 2 plus 0 is 2. 2 2s are 4, 4 plus 1 is 5. 5 2s are 10, 10 plus 1 is 11. 11 2s are 22, 22 plus 1 is 23. 23 into 2 is 46 plus 0 is 46. 46 into 2 is 90, 92. 92 plus 0 is 92. 92 into 2 is 184. 184 plus 1 is 185. 185 into 2 is 370. 370 plus 1 is 371. 371 into 2 is 742 plus 1 is 74. Take the answer from bottom to top. Take the answer from bottom to top. The answer is 10111. 10111. 10111. What did I do, boys and girls? What did I do so far? The given number, I went on dividing by 2 till I got less than 2. 2 1s are 2, divided by 0. 1 is less than 0, stop. Right? Should I do one more problem? Or should I do this? I think one more problem. Instead of taking 743, I will do a small problem. Okay? 79. What about 79? This is the problem, fourth problem I will do. Same. Okay. 97 of decimal to binary. This is the first problem, boys and girls. Here is the fourth problem. Should I do it? Yes. What is the number given? 97 of decimal to, come on, 97 of decimal to binary. If you want the answer to binary, keep dividing by 2 till you get less than 2. 97. Divided. 4 2s are, right, remember this 1. 1 and 7 is 17. 8 2s are 16, remember this 1. 8 2s are 16, 16 plus 1 is 17, remember this 1. 4 2s are 8, 8 plus 1 is 9. Again divided. 2 2s are 4. 4 2s are 8. 6 2s are 0. 2 3s are 6. 2 1s are 2, remainder is 1. I repeat again. 2 1s are 2 plus 1 is 3. 2 3s are 6, 6 plus 0 is 6. 6 2s are 12, 12 plus 0 is 12. 12 2s are 24, 24 plus 0 is 24. 24 into 2 is 48, 48 plus 0 is 48. 48 into 2 is 96, 96 plus 1 is 97. Take the answer from bottom to top. 1, 1, how many zeros are there? 1, 2, 3, 4. 1, 1, 4 zeros followed by 1. This is what the answer is. Now, should I do the second one? So these two are decimal to binary, decimal to binary. Now decimal to octal I will do it. Should I use the same number or should I change it? Number is immaterial. You need to be familiar with that. You need to be familiar with what? Table, that's it. Sir, why to take 743, 743, 743? Put any number as you like. Right? So what I will say is, I will do this second problem. Second problem is quite simple. 743 of decimal, 743 of decimal, you need to convert to octal. If you want this convert to octal, you need to keep dividing by 8 till you get less than 8. Do you understand what we are doing here? Because it's binary, we keep it on dividing by 2. Because it's an octal number, we keep dividing by 8 till you get less than 8. Is this clear, boys and girls? Quite simple. When I do it, what happens is 8 nines are 72. Remainder is 2. 2 and 3 is 23. 23 means how much is that? 8 3s are 24. 8 2s are 16. Remainder is 4 and 7. Should I repeat again? 8 2s are 16. 16 plus 7 is 23. I put 3, remainder is 2. 8 9 is 72. 72 plus 2 is 74. Again divide this one by 8. What happens is 8 12s are 8 11s are 88. 8 11s are 88. Remainder is 4. 8 11s are 88. 84 is 92. Again divide. 8 1s are 8. Remainder is 3. Take the answer from bottom to top. 1 3 4 7. 1 3 4 7. I repeat again, boys and girls. In octal numbers, you are allowed to use the digits from 0 to 7, not beyond that. If I use the digit 8 in octal, it's a mistake. If I use the digit 9, it's a mistake. So you are allowed to use in octal numbers 0 to 7, that's it. 0 to 7, not beyond that. Am I clear, boys and girls? I repeat again once again. 743. 9 8s are 72. Right? 9 8s are 72. Remainder is 2. 2 and 3 is 23. 8 2s are 16. Remainder is 7. To check what we have done is correct or not. 8 2s are 16. 16 plus 7 is 23. Remainder is 2. 3 I put, remainder is 2. 8 9s are 72, 72 plus 2 is 74. So what we have done is absolutely correct. Again, divide this. 11 8s are 88. Remainder is 4. 11 is 88. 88 plus 4 is 92. This is also correct. 8 1s are 8. Remainder is 3. Take the answer from bottom to top. 1 3 4 7. Okay. Should I do the last one? Or should I do one more problem? Yeah. Should I do one more octal? Okay. Here I do that. So that every time, everything we will do from each. So what happens is, I will take a simple number. Instead of 743, I take a simple number of your right. Possibly 1, 2, 3 of decimal to octal. Should I do 1, 2, 3? 1, 2, 3 of decimal number. Decimal to octal means keep dividing by 8. What happens is 8 1s are 8. Remainder is 4. 4 and 3 is 43. 8 5s are 40. Remainder is 3. Again, 8 1s are 8. Remainder is 7. Do you understand? 8 1s are 8. 8 plus 7 is 15. 15 8s are 15 8s are 120. 120 plus 3 is 123. Take the answer from bottom to top. 173 is the answer. 173. This is 123, you can say, but you cannot say this 107. So this you can reach it as 123. 123. This should not be pronounced as 178. It's 178. 178 of octal. 123 of decimal is fine. Octal number, hexadecimal number, binary number, every individual digit has to be read. Don't read as 1000. Okay? Now, in this case, what happens is we saw 1, 0, 111, 00, 111. This is how we should read. Or 1, 0, 111, 0, 0, 111. This is how individual digit has to be read. This should not be read as 173 of octal. So, in category. Okay. The last conversion. Decimal to binary, 2 problems we did. Decimal to octal, 2 problems we did. Now, decimal to hexadecimal, we'll do 2 problems. Quite simple. Boys and girls, you need to understand this very, very clearly. What do you need to understand? The hexadecimal is the only number system which has alphabets. You are allowed to use 0 to 9. You will not be writing 10 as 1, 0. Instead, you will be writing as A. 11 has to be written as, there are 6 alphabets are allowed. A, B, C, D, E, F. A denotes 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. 0 to 15. Right. Now let's take the same problem. 743 of decimal we need to convert into what? Hexadecimal. Should I do it out here? Should I do it out here? Okay. 700. Yeah. Now what happens is 16. What is 16? 16 5s are 80, 16 4s are 64. 16 4s are, because 16 5s are 80 with them. Right? So which is 74 only. Closer to that is what? 16 4s are 64. What is that? 74 minus 64 will be how much? 10. 103. 103. 103 again, if you divide by 16, what happens is 16 6 are 96. Yeah, divided is 7. I don't know how many of you understand. I think you may have to use your calculator. Right? I love to do everything verbally. Mentally, I love to do it. Okay? At this age, I am familiar with the 16 people. Right? You are teenagers, you have got lakhs and lakhs of brain cells, it is far active than me. So you should be knowing this. Right? Let me tell you. 16 4s are 64. So 74 minus 64 is what? 10. 1 0 and this is 3 digits there. So 1 0 and 3 means 103. 103 when you divide it. 16 6 are 96. Divided is 96 plus 7 is 103. Again divide this one. 16 3s are 48. 48 isn't there? Less than 48. So 16 2s are how much? 16 2s are how much? 32. Remainder is how much? 46 minus 32 will be how much? Remainder is 14. 14 should not be written as 1 4. Mind you, as I told you, A, B, C, D, E. 10, 11, 12, 13, 14. 14 has to be written as E. The answer is 2E7. The answer is 2E7. What is the difference between hexadecimal and other number systems? Quite simple. In hexadecimal number systems, we will be using the digits, 10 digits, 0 to 9. How many of them are there? 10. We will be using 6 alphabets. A, B, C, D, E, F. A represents 10, 11, 12, 13, 14. 14 because the remainder was 14 and put, well, not 1 4, I put as E. And the 15, if you get a digit, you must put F. There are only 6 alphabets are allowed in hexadecimal. And do one more problem, boys and girls, so that you pause this video, copy down all the 6. It's very basic. You will find in your forthcoming unit test such type of conversions will come. So you have to practice. You have to practice. Here I go. Which number you want to reverse this problem? Okay. Let me say no 70. 83 of decimal to hexadecimal. What I do is, I will do here only. This place is more than enough. This is the first problem. This is the second problem. This is the fifth problem. Here is the third problem. First, second, third, fourth and fifth. Here I go the last one. 83 of decimal. You need to convert it to hexadecimal. Hexadecimal means you have to divide by 16. 16 5s are IT. Remainder is 3. Because 5 is less than 16, stop doing it. Take the other thing, what we got? 5 and 3. 5 and 3 of hexadecimal. Okay, if I do more problems, you will get confused. So I will stop here. Boys and girls, what did I do? I put this and down. Today I taught you reviving of 4 number systems. Base 2 is binary, base 8 is octal, base 10 is decimal, and base 16 is hexadecimal. I converted from decimal to binary 2 problems. I converted decimal to octal 2 problems. I converted decimal to hexadecimal 2 problems. Pause this video, copy down this problems, then I shall refer your exercise and we will do few problems. Take care, boys and girls. Keep studying. Watch the video periodically. We have 2 classes per week from last Monday, right? So you must give any doubt. You can always contact me, okay, during the daytime, not for the night time. Certainly I will respond to your queries. Take care, boys and girls. Bye-bye.